Introduce our next speaker, Michael Geraghty. Mr. Geraghty is New Jersey's Chief Information Security Officer. He's also the first director of the New Jersey Cybersecurity and Communications Integration Cell, known as the NJCCIC. I kind of like that better than the NJCCIC. And that's the state central hub for cyber operations and resources, and Mr. Geraghty manages its day-to-day functions. Now that's my official introduction. What I need to say is that Mike put it together that his son and my son were on the same soccer team, 15, 20 years ago? Because we were walking around here saying, this guy looks vaguely familiar. And so, given his background in intelligence, he put that together. And actually, I first heard Mike describe the NJCCIC at a conference several months ago. And as a result of his talk, I signed up to receive their weekly cybersecurity bulletins. And these are really interesting. They're eye-opening and a great way to stay informed about the latest cyber threats, data breaches, and even cybersecurity education opportunities. So I encourage you to do that. Mike?
Good morning, and thank you for having me. Thanks for showing up. As Dennis said, I'm Mike Geraghty. I'm the director of the NJCCIC. The NJCCIC, for those that aren't familiar with it, is the state's one-stop shop for cybersecurity information sharing, threat intelligence, best practices, and incident reporting. So it was created in 2015 by an executive order from Governor Christie at the time. Understanding the fact that cybersecurity in the state of New Jersey is so important that we needed that centralized hub, the clearinghouse for information. While we've got big companies here such as Johnson & Johnson, Verizon, Prudential, and others that will have mature cybersecurity programs and functions, the majority of the small, medium businesses, municipalities, county governments do not have those resources. So we augment them. And we also play the role, and I'm the Chief Information Security Officer for the state of New Jersey, the executive branch of the state, which is Department of Treasury and Labor and Health and all of these others. So about 70 different agencies, 15 major departments. So we look both inside of state government and outside of state government. And so we provide services throughout. We're located at the Regional Operations Intelligence Center down in West Trenton, New Jersey, on the campus of the state police. That's our fusion center for the state of New Jersey. It's where all the intelligence happens as far as terrorism and everything else, and now cyber. But in that fusion center capacity, we're made up of not only Homeland Security personnel, but state police personnel, Office of Information Technology personnel, and then at the Rock we also have DHS and FBI, TSA, and other federal agencies. So it's this true fusion center capacity that we're bringing to bear on the cybersecurity issues that we have. So this is on data science. Data science only came about 15, 20 years ago. It coined in the 90s and stuff. So I'm going to talk about more of the practical applications because we've been doing this, and I've been doing this long before 1996 when this topic of data science came up. Predictive analytics, intelligence, all of those things have been around for a real long time. In fact, if you go back 1813, any math majors or physics majors, Pierre Laplace, scientific determinism, who basically stated, I'll paraphrase, that if you knew everything about every object, where it was in the past and where it is in the present, no matter how big or small, you can predict the future. Okay, and he wrote that in a philosophical essay on probabilities. And so that was like the first introduction to data science, if you will. Everything, when we talk about big data and artificial intelligence and machine learning, and being able to predict what's going to happen, whether it's on the stock market or any place else in the intelligence community, terrorists and stuff like that, it is this, as Borges said, the Library of Babel, everything about everything and knowing everything about everything. 1838 or so, Charles Babbage, and anybody know who Charles Babbage is? Okay, so you computing people, okay? He was the first inventor of the mechanical computer back then, and he actually stated that every utterance of a word that comes out of our mouths and all the molecules that connect with one another go on for infinite time, and they're going to interact with other molecules and transfer energy to others and stuff like that. So if you go to that, if a tree falls in the forest and nobody's there to hear it, does it really happen? Not only does it happen, but it affects everything in the world based on that understanding of data science. So trying to get all this information and all this data so that we can make these predictions, and that's kind of where we see data science. So I didn't steal this, Doctor, from your presentation. I had this myself, but all these terms are associated with data science and big data clustering. And it really refers to the collective processes, theories, concepts, tools, technologies that allow us to review and analyze data and extract knowledge from it. And that's really the purpose of this. All right. And as I said, data science is relatively new, 1996 or so. But the origins going back to Laplace, Babbage, and then 1948, just up the road here in Florham Park, with Claude Shannon and his Bell Labs Scientific Technical Journal, where he came up with information theory and everything being binary, a 1 or a 0. And now we can take anything in the world and know its information based on that. So lots of history here. But we're not going to talk about the history or the theory behind it, more of the practical purposes of it. Similar slide to Dr. Cantor before, and I didn't get this off from the CIA for Kids website. Actually made this up myself. But any intelligence cycle, there's a planning, there's a purpose behind it. Why are we collecting intelligence? And so there's planning that goes into it. There's the collection of all the different information sources, the data, the processing, and I don't know if anybody's a data scientist here, but this processing is probably about 80% of the work that you're going to do. The curating of the information, the parsing of the information, the cleaning of the data, and it's really, really tedious. Okay, but once we get all these data sources together and then we can start producing and disseminating, it leads us into this second part of what I call actionable intelligence, because if you're just producing intelligence reports that aren't spurring people into action, then it's a waste of time. If you're just creating noise out on the internet with reports, and I think of Twitter and all these other social media things, I'm going to the bathroom, I'm eating this for lunch, and that type of stuff. It's not necessarily intelligence, it's a lot of noise. So what we should be putting out there is not just information, but intelligence that spurs people to action. And that requires that all that data, the information that we turn it into, the analysis of the information that then makes it intelligence, and then that action that occurs after the intelligence is disseminated to individuals. We in cybersecurity have all sorts of great data. Data science lends itself to cybersecurity and solving cybersecurity problems. And one of the problems that we've had, if you've been in cybersecurity, is this insider threat or account compromise thing. And we get all sorts of logs. And this is our VPN logs, so virtual private network logs, for anybody that's remotely connecting into an information system over a virtual private network. So one of the things that we always want to do is look at the impossible traveler, as I say. Somebody that's remotely connecting into your services from two different locations at the same time where it's impossible to be, right? And these logs are structured, date, time, username, the session duration, the IP address, and this is typically what an analyst has. So there's not too much that can be made of this other than to say that we've got connections from these different users. So what we have to do is enrich the data, find other data sources to include with it to do some more analysis. So some of the other things that we can add to it is getting geolocation data for where these IP addresses are sourced from. The originating IP addresses in this state, this city, this country, and stuff like that. And you can see now we can make a little bit more sense of what's happening. We can filter, and this is simply Excel. by country and different places. Well, if we have state employees, why are they logging in from Canada and elsewhere? What's happening there? So an analyst might pick up on that because they're reviewing this. What's happening outside of the state of New Jersey or Pennsylvania or New York, where some people may live. And so finding this in rows and columns is really hard to do. So we've got to look at it in other ways, doing the analysis, visualizing the data. And basically, we can take the map of the world, and then we can place those IP addresses there. And the first thing that this shows me as the CISO is, oh my God, somebody's logging in from the Ukraine. All right? And that's, you don't see that in the rows and columns necessarily. It doesn't jump off the page at you. But here you can, and you can see these things, and you can now start investigating, leading you down, other avenues of inquiry and stuff and other analysis. So we visualize the data, but having somebody in the Ukraine, okay, what else is happening? So we want to look at the times that people log in and where they're logging in from. And we just so happen to see that this one individual not only logged in from the Ukraine, but at the same time, he logged in from Costa Rica and from down in Houston, Texas, which is really kind of impossible to do within an hour, no matter how fast that plane is that Dr. Cantor's flying all over the place. So these things tell us that we've got a compromised account, or somebody shared their password with people that they shouldn't be sharing. Now this leads us into something else. So now this analysis can take us into action. One, we're going to cut off the account, obviously, and two, we're going to do further investigation. But it's by getting these logs, enriching the data, doing the analysis, publishing it, presenting it in a way that means something that is really valuable. It's not just rows and columns and those types of things. We in the NJCCIC, we guard or we're the monitor for the Garden State Network. And the Garden State Network is the state network for all the executive branch agencies, the Turnpike Authority, New Jersey Transit. Just about every municipality will connect into the Garden State Network. If you were coming here today and you got pulled over by a police officer and they ran your plate, well, they're going to log into the Garden State Network to run your driver's license that connects into a mainframe in Trenton in order to do this. So we look at all the attacks against the Garden State Network. This is the month of August. The good thing about this is we're not a classified agency, so I can share information and not have to read from notes. So as you can see, 7 million attacks from within the United States, so we're our own worst enemy. But that big country off to the right is Russia. There's 6 million attacks against Garden State Network. We have about 100,000 IP addresses that make up this network. And so we see all sorts of attacks. And these are great to show the boss, especially when you're looking for funding. Oh my God, Russia is attacking us. And oh my God, China at 156,000. But even the Aussies, our friends down there, are attacking us, or IP addresses that are located in those countries are attacking us. And France and England, and then even our friends up in Canada, and I don't know if they're friendly now with what President Trump and Prime Minister Trudeau are doing, but so 3 million attacks from there. So lots of good information here, and you say, oh my God, wow. But if an analyst would present this to me just as a slide in a PowerPoint, it's meaningless. Because I want to dig into the attacks. I want to know more information about it. We can't just print pretty pictures. It's got to be more actionable intelligence. You got to be able to drill down into it. And so we use all sorts of tools, and Paul was talking about Elasticsearch. That's our go-to. That's our platform for all our big data. But we also use visualization tools and other analysis tools. This is Tableau. I'm a big Tableau fanatic, and only because it's easy to use. I'm not a programmer, so I don't have to do all sorts of programming to get it to run. So if I go into the intelligence that I get from the attacks coming from Russia, there were 6 million or so. But if I just look at the critical ones, the ones that if they were successful, they would lead to owning the Garden State Network, okay? And then I can look at the different types of threat categories, the different countries, and I can drill down into this. And we can see different patterns emerging. What we were seeing of those 6 million, most of them were actually attempts to hack into VoIP systems. So voice over internet protocol, VoIP, they were SIP attacks, basically probes for those types of things. But oh my God, 6 million, then you get into it. And the only reason we know this is because we blocked it all. So none of this was successful, which leads me to the next point. This is what it's telling me, but as the CISO, as the director of the NJCCIC, I want to know what it's not telling me. These are the tools, the technologies that we use to detect and block all this stuff. But we want to know all the other connections. So we look at all the other logs, not just those that got blocked, but those that actually came through, what was going on, and digging into that type of stuff. So lots of intelligence here, and we use this to determine what we're going to protect, how we're going to protect it, our strategies, our tactics, and all this other stuff. So as I call it, intelligence-driven security, not checkbox security that you see in a lot of these cybersecurity frameworks. You have to have antivirus, you have to have this, you have to have that. They're all well and good, but I'm more interested in what is the data telling me, because that's going to drive our program as we go forward. Visualizing data. So over the past year, we had about 25 or so police departments in New Jersey get hit by ransomware. And when they get reported to the NJCCIC, we look into it, we work with the state police, we work with local police departments. And what we found is that all these police departments that got hit use computer-aided dispatch records management systems, CAD RMS systems. And the way that the patrol cars with those mobile data terminals connect into the CAD server is over RDP, Remote Desktop Protocol, which is a Windows thing. So this way they can receive calls in the car. And what happens is RDP is exposed to the public internet, which means not only do the patrol cars get to connect into it, but anybody else can try. And so one known method of spreading ransomware is actually hacking into RDP and doing brute force attacks on username and password. Okay, police departments are really secure, so the password is probably the name of the town that the police department is in. And so this became a problem, and the pattern started to emerge. So what we wanted to see was how many victims were in waiting out on the public internet in New Jersey that had RDP exposed. And this is another, we take this information from open source data. Shodan, I don't know if anybody uses Shodan, but they scan systems and they publish the data. We get that data, we throw it in here, and we can visualize it by zip code. And as you can see, and I don't know if anybody's looking closely, but Rutgers University has 82 systems that are exposed to the internet using RDP. So victims in waiting, the big numbers up there with those Chupa LLC and InterServer, those are virtual hosting sites and servers and stuff like that, default configurations that haven't been secured. But there's a lot of others out there. So I mentioned one of the missions of the NJCCIC is to information sharing and threat intelligence. Where we can identify the owners of these servers, we're going to notify them that they're set up insecurely. And they should take, here's the best practices on how to secure RDP, and you really should be doing VPN or some other thing that would be a more secure remote communication method. So when we think of cybersecurity, the other intelligence, the practical intelligence that we get out of here, and you're not going to see this in any slide, is it's similar to, I'll go back to the woods here, if you're in the woods and there's a bear, you don't necessarily have to be faster than the bear, you just have to be faster than the slowest person in your group. And these are the slower people in your group. These are the people that are leaving their keys in the car ignition with it running at the mall. They're the ones that are going to be hacked and stolen. So just having minimal defenses, some good cyber hygiene is going to protect people. About almost 2 years ago to the date, we had the WannaCry outbreak, and the WannaCry was ransomware that was affecting over in the UK, Europe, Asia, and stuff like that, and it was starting to spread to the United States. And so this was all over the internet, all over Twitter. We monitor Twitter, we have TweetDeck. We're looking to see what's happening in Asia, what's happening in Europe, because what typically, like the stock market, what's happening overseas is eventually going to impact us here. So we were looking at this outbreak of WannaCry over there. First thing that we do in the state is say, okay, do we have any Windows servers exposed to the public internet with SMB version 1, which is an older version of SMB, and it's since patched long ago by Microsoft. We didn't in the state, but we started to look for it, and everything internally we started to patch just in case WannaCry got in. But then we started to look at what's happening within the greater state, not necessarily state government agencies, but again, by zip code, we can see the servers and the numbers there that had this vulnerability exposed to the public internet. Again, potential victims that were there. That weekend, because it happened on a Thursday, Friday, Saturday, Sunday, we were working with NYPD. NYPD had us do the same things. Can you tell us who the potential victims in New York City are? What are the businesses and those types of things? So these maps are great. There's a lot of underlying data to it as far as the IP address, where it's located, the host name, maybe, and pulling together all sorts of other information that we can identify these cybersecurity issues. So we use all sorts of data to lead us into our not only tactical operations, things that are happening right away, but on the strategic front as well, long-term things that we're looking to produce as far as intelligence is concerned. I mentioned ransomware a couple of times, and ransomware has been the big news in, as far as cybersecurity over the last 2 years or so. It's been the most common infection and the most destructive as far as it impacting individuals. But what we've seen since especially February is the uptick in what's called an Imhotep Trojan that's being distributed via email. So coming into New Jersey state government email addresses, we have about 67,000 employees in state government. They receive approximately 4 million inbound emails per day. That's what's coming in. 85% of those emails are filtered by our mail filtering system. 85%. So only 15% is legitimate. The 85% is being filtered because it has malware, it's phishing, and those types of things. The Imhotep Trojan, as I mentioned, was a banking Trojan that was created back in about 2014. If you got it on your system and you visited your banking website and you put your username and password in there, it would capture those and allow the bad actors to log into your bank account or financial services account. It went dormant for quite some time, but back in February it started to pick up again. And now this is the major uptick that we see. And it's not just the banking Trojan that's stealing credentials. It's also downloading all sorts of other nefarious tools onto your system, an Outlook scraper. And the Outlook scraper basically goes into your contacts in your address book and then starts sending out emails similar to the phishing email that purportedly come from Mike Geraghty to Dennis Egan. So Dennis says, oh, it's an email from Mike. So he's going to click on it, open it, and click on the link because it looks like a trusted email. And so this has been a big uptick, and we see all sorts of infections. We were just down at a private company and doing incident response. They got hit with Imhotep just a few weeks ago. We did the incident response down there, rebuilding systems, tracing it back, and sure enough, it came from an email that came like it was a trusted source, but it spread across the network, got blocked by the SCADA firewall. Okay, SCADA being all the bad things or all the things that could really do damage behind it, but this is big. Allentown City, which is over in Pennsylvania, they got hit for over $1 million. There's a whole bunch of other issues or incidents that are reported in the news as well, and we continue to see this hitting all sorts of folks and stuff. Beyond just those pictures and numbers that we see, and that's not a great graph, but it's a graph nonetheless, to show over time and how many of these that we're getting inbound and how many that we're detecting. The neat thing about Imhotep is that it's polymorphic and it uses artificial intelligence. So it changes the code with each email. So if you're basically using signature-based antivirus or filtering software, you're not going to identify these because you're waiting for your vendor to have that signature to put into the program so that you can put it on your system to identify it. So a lot of these programs that we use, a lot of the security tools that we use also use artificial intelligence. However, with mail filtering, what we see is a lot of it gets through. So we block 85%, but the first version of just about every new attack, every new phishing email is getting through. And it isn't until they get a few of these that they can put it together. So this is really important as far as security awareness within companies, within school, within anywhere. Don't click on links from emails that you get from unknown sources. Don't open attachments. Nobody sends invoices as Word documents, okay? And those invoices never have macros that connect to other servers and stuff like that. So don't click on it. I used to be the CISO at Hudson's Bay Company, which is Saks Fifth Avenue over in New York, and it was a standing joke that the CFO would never open emails from the CEO because he always thought it was one of those business email compromises. And so that was always a joke in the boardroom and stuff. And he loved it because he now had an excuse to ignore the CEO. Beyond the pictures and numbers, what we're trying to do with all these emails, all these links, all these source IP addresses, as you can imagine, the 4 million emails that we got coming in a day, all those attacks that we see on a monthly basis, all the other network traffic, we analyze, we have about 1 billion events, network events that happen on our network on any given day. So within 24 hours time, we're analyzing 1 billion events. A lot of that is done through the tools and technologies that we use. But that intelligence that we receive of these types of attacks, that's the type of stuff that we're putting in that bulletin that Dennis mentioned before that goes out on Thursdays, so that we can advise others that these are the trends that we're seeing over this past week. These are the things that you need to do to protect yourself. We also send out alerts and advisories on a daily basis, depending on what the topic is and what the alert may be. So if we see something that needs to go out to our membership, we'll send it out. I mentioned the membership. Membership in the NJCCIC is free. You go to our website, cyber.nj.gov. You sign up, tell us what sector you're interested in, a critical infrastructure sector, whether it's government, banking, or energy or something like that. In this way, we can send you alerts that are relevant to what you are interested in, and we don't become a spam source. So that's some of the stuff that we do. So I mentioned my time at Saks Fifth Avenue, but I was also the CISO and the CIO for the National Center for Missing and Exploited Children. And the National Center for Missing and Exploited Children, we have a team down there, Exploited Children Division, and within that team is the Child Victim Identification Program. And on a weekly basis, our analysts receive over 1 million images and videos submitted by law enforcement that contain child victim images, okay, child pornography, if you will. And we used hashing algorithms, cryptographic hashes, one way, MD5 and SHA, in order to identify identical images or identical files. And it worked great as far as identifying identical files. Where it fell down and where it was really tedious is when you had two images that, in this case, it's a windmill.jpg and a windmill.gif. They have two different MD5 hashes, but they're visually the same. So we talk about visual recognition and being able to identify these things. This becomes a problem when you only have 16 analysts and they're getting 1 million images a week. And these, by law, the National Center had to provide victim impact statements, identify victims, provide it back to law enforcement, and it was taking about 12 weeks to get through a case, right? 12 weeks that law enforcement was waiting to actually charge to see if we had a known victim, a known child, because if it's not a child, you can't charge with child pornography. So we had this problem. I was the head of the Technology Coalition. The Technology Coalition at the center consisted of companies like Google and Facebook and Yahoo and Microsoft and others and stuff. And we explained this problem, that we were just getting too many images. The analysts couldn't keep up. So Dr. Hani Farid out of Dartmouth, he started working with Microsoft Research and came up with something called a photo DNA signature. And it's robust hashing, it's clustering, but instead of having an MD5 signature, now we had a photo DNA signature that was a little bit longer, 144 unsigned cars or integers between 0 and 255. And we can start creating signatures. So the way that photo DNA was going to work for us is that it was going to take any image, any size, as long as greater than 50 pixels. And then it was first converted into a grayscale format. And then it would downsample it to 26 by 26 pixels. And then it would break it up in cells, 6 by 6. And then it would calculate the histograms in there, and it would come up with the photo DNA signature. And now what we could do is take those signatures, and if you've taken geometry and Euclidean distance, you can go back, and now you can start doing P1 minus P2 squared, okay, the square root of that. And now you have a Euclidean distance between the two images. And through the research that he did, and Dr. Fareed, being an image specialist, we came up with a variance tolerance of 41,943, I believe it is. So if we had a distance below that number, we can say that they were visually similar images. So we were able to cluster these images and really reduce the time that it took for our analysts to go through them, because now no longer were they using MD5. We're using visual recognition type stuff. So in this case, those two windmills, the distance is 107, far below that 41,943. Now, I think Paul, you mentioned, or Doctor, you mentioned, is actually verifying that the science works and the algorithm works. And I remember I'm 50 years old, I'm sitting in my house in Cranford, and I'm doing this by hand because I didn't trust the algorithm. And I want, and yeah, it gets, with 144 characters, it's a lot to do. And so Euclidean distance, Pythagorean theorem, all these other things. And my son comes in, the one that worked, that played soccer with Dennis's son. And I said, Larry, do you remember, Pythagoras? He goes, did he play for Brazil? So he wasn't a math major. So anyhow, Euclidean distance, you figure this out. So we started to do more sampling, and all these samples are from vacations that we took as family. I knew what the resultant would have to be in order to prove it was true. In this case, Grand Teton National Park, we can see that there's a bear and her cub. And we can see that the Euclidean distance is 31,636. They're visually similar. A little bit different in that the cub and the mom are close to one another, and then in the second image, they're a little bit further apart. But we can say it's the same image or visually similar, and we can cluster those together. And it works really well. It's now used all over the world. Law enforcement uses it to identify visually similar images and to rescue children. So the use of this technology and use of these types of algorithms is really good, okay? But they've got to be verified. They've got to have a use case. And one of the things about data science that, data science for doing data science is nice, and it's abstract, and it's science, and Dr. Cantor mentioned the difference between engineering and science. But what's missing from the data science curriculum and all the kids that are coming out knowing R and Python and linear regressions, Bayesian filters, and all these other things is, what question are you trying to answer? And that's really the crux of data science. Not showing all sorts of different graphs and stuff like that, but what is the question you're trying to answer? What are the correlations you're trying to make with data science? The practical application of it, as I mentioned before. So we've got algorithms, and algorithms have boundaries. And if we do a time lapse of a rose blooming, we can see those two pictures are 602,000 apart. A lot more than 41,943. Not visually similar at all. However, if we apply the algorithm wrong, what's going to happen is over time, we're going to be able to see the first two images in the series are within that distance, okay? We'll cluster them and say they're part of the set. And then we can see that the third image is close to the second. And if we did this wrong, we would apply that to that same group, all right? And as we go down, all of these are within that 41,943, but when we get to the end, we have the fully blossomed rose with the rose bud, and they're not visually similar. So not only knowing the algorithm, but the application of the algorithm and why we're doing it, what it's supposed to give us, is really important when we talk about data science. This is cool stuff. I love it. We could talk all day about this. Hani Farid was hired by Microsoft Research to do this, and I got to work with Microsoft Research and Google and Facebook and all these, other great engineers and stuff like that. So Google wasn't to be outdone by Microsoft. So we had another problem. We had a case where we had a young female who was being raped, and there was a bed and that she was on, and the analyst got it and said, "Oh my God, okay." And what was notable about the picture was that there was a bedspread that had a unique pattern. About a month later, she got another case coming in. Different female, same bedspread. If it wasn't for that same analyst having it, there's no way that we could identify that it might be the same suspect that's doing this. So what happened is Google engineers heard this, and they came up with something called visual search for us. And basically, we could rubber band, and we rubber band the Let's Go cap sign, and then we can search across a corpus of images that we have and find any other image that has that Let's Go cap sign. Doesn't matter if it's black and white, upside down. Doesn't matter if it's in another person's cubicle. It allows us to find these things. So the image search, the visual search is amazing. When we look at the background of images, phone numbers or shopping bags that have the name of something on it, we can now find those things. Pictures on the walls, diplomas that are hanging up in the background, types of telephones. Those are the things that lead the analyst at NCMEC to identify possibly who the child is, where it happened, when it happened, and all these others, and obviously provide police with a suspect. So these algorithms, the advanced intelligence, the artificial intelligence, the machine learning that we get from doing things over and over and over and learning from those types of things are some of the really neat parts of data science and what we're trying to do. So some of the other practical considerations, I struck the one thing that stood out in Paul's talk is that he provisioned a server in 3 weeks in a government agency. We can't get a purchase order done in 3 weeks, never mind provisioning a server, okay? But having the ability to do certain things. It's not like you're going to walk in and say, okay, folks, let's stand up an elk stack, Elasticsearch, and we're going to do all this today. There's all sorts of things that we've got to do to make that happen. So if nothing else, I'm going to find a way to get things done. And having COBOL programmers that work on mainframe, they probably aren't familiar with elk stacks, okay, and containers and those types of things that we're going to use, distributed computing and distributed storage. But there's a lot of kids in the back of the room that probably know this inside and out, and we know that throughout the colleges in New Jersey we have. So we have a great internship program is where I'm going with this. And so through our internship program, we got some kids, and it was from NJIT, and to build out our elk stack, which is the crux of our analytics engine. We've got Rutgers students that came in as interns that are now our data scientists, that are now writing the grok parsers and pulling together all this information so that we can do the correlation across our email data and our Palo Alto log data and our VPN data and all these other things to find out all these problems and stuff like that. So the internship program, the way it works is you come in, you get to work on real problems, cool problems. You don't make coffee and you don't do files and stuff like that. If you do well and you like the project and we like you, we're going to give you a part-time job to keep you going through college, okay? And then after college, if you really want to stay and you really like us, and most of them have, we'll offer you a full-time job. Those that haven't stayed, they've gone to the NSA, they've gone to AT&T, they've gone to Verizon as security engineers. And the common refrain from every one of them, no matter what college they went to, is they learned more during their internship and their time with us doing cybersecurity than they ever did. And not all of them were cybersecurity people. Some of them were math majors and just, well, we get data analytics major as one. But having that ability, so we're going to find the ability. There's lots of people that can do this, not necessarily that we have them all today. The relevance of the information that you're parsing and what are the logs. And I'm an admitted logaholic. There's no piece of data that I don't want, and I drive the team nuts because I'm always looking at data and have more and more data. So we've got to build out big data stores and stuff. So we go rogue and do that. The accuracy of the data, whether it's older databases or newer ones, garbage in is garbage out. If you're putting in bad information, you're going to do bad intelligence, bad analysis, and bad actions in the long run. Scaling these things is really difficult to do. So Paul mentioned Amazon. There's Amazon, there's Azure, there's Google Compute Engine. There's all sorts of ways to do this where you don't have to provision servers. We don't need a server per person or anything like that. We can do VMs and containers and all sorts of ways to do this. We got to go beyond the eye candy. So those pictures are pretty. But do they mean anything? And the meaningful intelligence is really what. And then return on investment. So whether you're in cybersecurity or any other form of law enforcement intelligence, there's so much data out there. Being able to ingest it and then being able to make sense of it is what that return on investment is. It's not going to make you money unless you're in the private sector. But in intelligence, it's going to allow us to prevent attacks, whether it be the World Trade Center on 9/11 or other things as far as cybersecurity is concerned that we deal with. Tools and technologies, some of the things that you saw up here that I use and I'm a big fan of, Excel, Tableau, Nuix, it's a forensics tool, if you will. Splunk is another one that you log parsing and data analysis. Palantir, at the center, one of the great things about NCMEC is that it was a public-private partnership. It was a nonprofit. So all of these companies, the Googles, the Facebooks, the Palantirs, wanted to be great philanthropic models, and they would provide us with engineers and technologies. Buying Palantir for the normal police department is not going to happen. It's very expensive, but it's a really, really powerful tool. Elastic, Kibana, R, Python, all these other tools and technologies, skill sets that you have. You know, it used to be infrastructure people would spin up a server or provision a server. Well, now it's the developers. Okay, and infrastructure is being handled by developers. So a lot of those skill sets kind of go away, and they've got to be part of the development curriculum, how to do this, because when we're using containers, we don't need a server. Okay, we just need the code that's going to launch that and run it. So all sorts of cool stuff there. As we go forward, this is the thing that scares the daylights out of me. Everybody's got a smartphone. Most of us have smart TVs, smart thermostats, smart locks, and doorbells and all these other things. And we're moving into smart technologies as far as intelligent traffic systems. Had them for quite some time, about 15 years now, where we have cameras on bridges and things of that. Those cameras are connected to networks that are connected to other networks, and those cameras have passwords and usernames of admin or admin1234, because when they were put in place 15 years ago, nobody thought about that. When they were using Windows XP as a black box, embedded XP, nobody thought that we would ever have to upgrade these things and all the vulnerabilities that but these are all connecting into networks, and we're going into smart cities at some point. I know there's an initiative in New Brunswick to have an innovation hub here, but we're thinking of the conveniences of the smart cities and the smartphones and all these smart devices, but not necessarily what it means from a security perspective. So one of the things, and this strikes me, is I was in another one of my careers, I was with the state police, and I started the high-tech crime unit back in the 90s. We have law enforcement that respond to 911 calls for crimes. We have fire departments that respond to fires. We have EMS for medical emergencies. We have hazmat teams that show up when there's a spill or something like that. At some point in the future, along with our smart cities, we're going to have cyber first responders. Somebody that's going to be able to reboot the city or reboot the lights. Because who are you going to call? Ghostbusters? It's a real problem that we're going to have to deal with, and governments, municipals, small, that don't have good IT departments or don't have cybersecurity postures are now running full steam ahead with this because they think of ratables, how many people are going to move in, but not necessarily what the costs are going to be longer term and with all the nefarious things that go on here. You see all the attacks against the Garden State Network. those same attacks will go against these smart cities and all the different devices that are connected to the internet. So whether it's, you know, health systems or any other types of systems, we got all sorts of issues that we've got to deal with. So this is a great field to be in, data science, cybersecurity. When you interview for a position with the NJCCIC, I really don't care if you know anything about cybersecurity. That can be taught. But to do critical thinking, to do logic and do those types of things and work through problems, that's really what we're interested in. If you have a background in scripting languages, whether it be Python or other things, that's where we want, you know, we want to take that. You're not going to build gigantic, but we need tools to connect all these different things. We all these APIs that we have so that we can, you know, correlate all that data. So if you have any questions or you want to contact us, we're online, whether it be Twitter, or you can contact us, you know, at our website or via email. That being said, any questions? I think I have a few minutes, or what do you got? I got 1 minute for questions. Doc.
This is a great talk. At the very end, you talked about the need for who you're going to go to reboot the smart city. But it seems to me if there's a guy who can do that, then there's also a single point of failure that you've created.
Yes. Yes, yeah. And these are things that we're not thinking through. And those are the basic cybersecurity, the contingency plans, not the cool technology stuff. But what happens when we do this? The incident response, how do we recover from it? Do we have backups, you know, and how does this fail over? And whether we fail safe and fail secure, all those different types of things that we deal with. Okay. No other questions? I guess I explained everything perfectly, that I left no questions unanswered. All right. Thanks for your time, and I'll be around if you have anything offline.